So the next step is to move into actual coordinate geometry proofs. And when you see the word proof, in this case, we're not talking about statements and reasons like we learned with side angle side and similarity proofs and all that. This is a different type of proof. It doesn't look like that at all. You're actually going to like this one quite a bit better, probably. So on page 23, you're going to see all these crazy steps. Don't be intimidated by that yet. We're nowhere close to that yet. The only thing I want you to see is that step 2 and step 3 talk about slope and distance of each side of whatever shape you have. So that's why doing the slope and doing the distance is really what today is all about. And forget about all the other stuff for now. Both of which you know how to do, but we're going to review it. Slope, in fact, it's easier than this because you can just count boxes on the graph. So you don't really have to perform this calculation every time. And distance is actually easier than this because I like to show it using the Pythagorean theorem, which is really this anyway. Okay, so what I want you to do is go to page, here's all the reasons we're going to talk about later on, but go to page 25 and number 1. Now we can't do this yet. It's asking you to prove something as a parallelogram. We're not going to do that yet. We're going to start it, and then that's it. So go ahead and plot this. -4, 2, -2, 3, 0, -3, and -2, -4. Make sure you label A, B, C, and D. Give yourself a second, pause the video, and plot that. Okay, now this has 4 sides, right? So we want to find the slope of all 4 sides and then the distance of all 4 sides. So here's one way you could look at it. Slope is the letter M, if you remember, right? So the slope of AB, and then we'll find the slope of B to C, and then we'll find the slope of DC, and then all the way back around, the slope of AD. So there's the 4 sides. 1, 2, 3, 4. Okay. Then we're going to find later on the distance of that same AB, the distance of BC, the distance of DC, and the distance of AD. Okay. So 4 slopes, 4 distances, and don't even worry about y yet. It's going to be having to do with these reasons later. But right now, let's just practice our skill of slope and distance. So slope of A to B, right here. To get from A to B, you go up 1 over 2. Up 1 to the right 2. So the slope of AB is 1/2. Now, from B to C, that looks like we're going downhill. So we're going to go, you always have to go up or down first. So down 1, 2, 3, 4, 5, 6 over 2. Down 6 to the right 2. So I come over and I write down 6 to the right 2, which reduces to -3, or -3 over 1. Then we move on to D to C. D to C is uphill. It's up 1 over 2. Up 1 over 2. Maybe you notice something right there. We'll talk about that in a second. Then the slope of A to D. Looks like we're going downhill again. So down 1, 2, 3, 4, 5, 6 over 2. Down 6 to the right 2. Down 6 to the right 2 reduces to -3. So what you noticed here is these two are the same. So I usually link those up with a little bracket. If they have the same slope, then you have parallel sides. And look what happened here. These two are parallel. So here we have parallel sides again. So we just discovered that we have two sets of parallel sides. That's super important in coordinate proofs. Then, if we're going to find the distance, this is where Pythagorean theorem makes it a lot easier than using this formula. It's really the same thing. What you don't notice in here is that that's really a squared, that's really b squared, and before you take the square root, that would be c squared. So it really is the Pythagorean theorem. But it just seems easier when you do it this way. Let's find the distance from A to B. Now the distance of this is really just the hypotenuse of that triangle. And the sides, the legs of that triangle are 1 and 2. So this would just be the hypotenuse. So if I go 1 squared plus 2 squared, I end up with 1 squared is 1, careful there. 2 squared is 4. So 4 plus 1 is 5. And this is going to be weird looking, but the answer is just radical 5. Now, you're probably thinking, because we figured it out with slope, that this one down here is going to be the same. And you're right, because 1 and 2 are the sides of that again. So if I come down, what was that, DC? 1 squared plus 2 squared equals c squared. It's going to be the exact same work because the sides were the same. So c equals radical 5. So now we have two sides that are exactly the same, radical 5s. And if you haven't guessed yet, what's going to happen with these two sides? They're going to be the same because they're parts of these triangles. You have 6 here and 2 here, and you're trying to find the hypotenuse, and that's AD. So 6 squared plus 2 squared, 36 plus 4 is 40. So if we take the square root of 40, that's our answer. Now you could break that down. Just good practice, right? Radical 4, radical 10. So we could say that that side is 2 radical 10. And we're pretty sure that this one is going to be the same because we have 6 and 2 again. So it's going to be the exact same work. Watch. It's going to be the same work there. So now what we have is 2 congruent sides right there, the 2 radical 5s, and 2 congruent sides there, the two radical 10s. So what we just proved is more than enough information. We had 2 sets of parallel sides, half, half, and -3, -3 for slopes. And we just proved that we had 2 sets of congruent sides, radical 5, and 2 radical 10, 2 radical 10. So if you can just understand how to find 4 slopes and 4 distances, you are 3/4 of the way through a coordinate proof. And we'll practice that more as the week goes on.